Hello craftspeople, welcome back to Yummy Plays, where Yummy plays, and today I want to bring you the second part of my Teyvat Sports Day game that I created for Miliastra Wonderland, and today I'm gonna feature the high jump. So what you need to build a fully working high jump like this was a bit tricky with basically just collisions, but I will try to wrap it up here. So what I did need to make the high jump work, much according to our sprinting stage we had the last time, I have a box that will make the player ready and set a variable. Then I have a giant collider box that measures the height in where the player actually collided. And then we have a landing which is somewhat similar to our finish line. Something that just checks whether everything was correct. In addition to this, the high jump also features a high jump bar that needs to be at some height that cannot be touched, otherwise it will fall down. And these are basically the four components or four entities that we need for this. It is actually 5. So we have the height check here. So our setup is basically start, height check, landing, the real bar that we are going to move up that has a collision, and one falling bar that is only here to visualize when someone has hit the bar, because it will play a projectile motion device to just fall down. And with these 5 entities, we are able to model our high jump. For the decoration, I went quite similar as with the other ones. I used toy blocks for the red sand and used a carpet, which makes a surprisingly good landing mat. Other than that, I have some static poles here just in the environment, and our high jump pole, which hovers at 2 meters in the beginning. For this particular discipline, I found it quite useful to have an instructor also that has certain tabs that you can send the pole to like specific heights. Okay, then let's do a quick recap of all the entities that are needed for this. The first one that we need is the jump start. It is a big box that has on-hit detection. This could also be a collision trigger though. It is really only important that we get to know whenever a player walks in here. So the logic for this is quite simple. Basically, when we have an on-hit detection or when a collision trigger enters it, when you use a collision trigger, we just set the is jumping variable to true, basically, as if the character is not jumping. The next part that we have to do is our height check. So at this point, we do assume that somebody made it over the bar, not under it. And this height check has to be high enough that a character that is jumping at max height here still collides with it, and you can check where that collision happened, whether it happened above or below. And so we go here and to the height check node graph, which has some logic to check whether it is actually a character that passes in. By the way, for this we do need an on-hit effect, because this gives us the on-hit location. If you have a collision trigger and a collision trigger source, you will be notified when that entity enters, but not where. And this is why you sometimes need to have an on-hit effect, because this will tell you whether our player actually went over or below the bar in this third step here. But first we are checking if the character actually came from the jump pad. So is jumping set to true? Yes. Then when the actual on-hit location was higher than our bar entity's height, or the custom variable that we have set in the bar height, we will come to that in a second. When the on-hit detection is higher than what is currently stored as a height for our bar, then we set our height custom variable on the player to store the current height or whatever he managed to a valid attempt for the current height. And if not, then we set height to 0, because 0 is never a valid attempt. And this is very important, because we are setting variables on the player entity here now that needs to be read as soon as our player lands in the high jump land, which also has an on-hit detection. Could also be a collision trigger though, not important. What is important is that we have the attached node graph, high jump landing, the third one in the line now, and this node graph, it is not very tidy. I'm very sorry. Basically does the same check. This is actually a character that just landed here. Either way, set the jump attempt to false now, like we're done jumping. And if the height is still higher than 0, so we assume that the player actually crossed over the bar, then we reactivate our pole and submit our high jump to the stage entity. And in the end, we also reset the height that we stored on the player just to have a clean new attempt later. Again, here I have 2 submit scores. This is true for all of the disciplines that I'm explaining. But this submit score signal only holds true when you use my leaderboard Miliastra asset. Other than that, I will show you how to handle this in the stage entity by submitting a submit high jump event here that takes a player name, a character name, and a valid height. So yeah, that is basically the whole logic for the high jump. But to make it a bit more interesting, we also want a high jump pole here that we can hit and that then should fall down and also fail the attempt when you hit the pole. So to make that happen, we just take a pole, like I literally took a pole arm. What we do need on this though is an on-hit detection. The collider should be really only just as thick as the pole itself, so as soon as you touch it really, it should fall down. And what we also need to have a smooth transition. When we change the height via signal, we want a basic linear motion device attached that we will start via node graphnator. And that brings us to the node graph for the high jump pole. Basically, as soon as you touch it, as soon as a character touches it, we set the height of the character to 0, so invalidate their attempt, and set jumping to false, basically just fail, and we spawn the falling pole. Also, as we really don't want this bar here to be present anymore, we have to disable it, as well as the height check. So one important thing for this here is that we actually have an entity deployment group for the high pole and the height check. As you see, in this entity deployment group, I have the high jump pole and my high check because these will be disabled as soon as you hit the bar. So that the high check doesn't really like try to get you through and count as a valid attempt. No, we will just deactivate this entity deployment group. So that doesn't happen. Other than that, from the outside, we also want to be able to reset the bar from our instructor, or when someone failed an attempt, I want to reset the bar to 2 meters. So I also implemented a reset bar signal here, which basically just tells the bar to enable itself again if it's disabled and set its own variable height that we are also reading in other entities, and basically have a smooth transition to this height. The last object that we have here, the falling pole, is a very simple asset which just has a projectile motion device to let it fall and a very simple time to live node graph attached. I will also show that quickly, but this is like a very standard node graph that you should have anyway. All it really does is to, after a configured amount of time, like here 3 seconds or 3 seconds, it will destroy the entity. It's just to make sure that these don't exist forever when you spawn them. And yeah, after we discussed the objects that are needed for this, you basically only need to have the right custom variables. Don't be shocked, it is a lot, but the first here are for my Miliastra resource center assets if you want to use them. Basically, the only 2 important variables here for our player is a bool is jumping and height, which is a float. As always, in my example, we wouldn't even need a collision trigger source, but usually if you don't care about the on-hit location, then it is cheaper to have a collision trigger instead of an on-hit effect. And similar to how we did it in our last example for the racing game, we also have high jump scores in our stage entity, 3 at that we want to display in our UI. Analog to that, in our stage node graph, we are listening to the submit high jump signal, iterate through all of our scores, see whether one of them is bigger than the one before, and it will insert it into the list and break the loop, and then we truncate our score list to 3. In the UI, we are just displaying our variable, our high jump scores 0, 1, and 2, and then we get a fully working high jump. There is not a lot of filtering logic here, so you can still have in multiplayer like one player having all the 3 high scores. It is a very simple ranking logic, but for my use case it was definitely good enough, and I hope it shows you how you could maybe tackle something like this, like a fully working high jump. I really hope that helped you a bit. If you want to make it more like my version, then you are free to download the asset pack in Miliastra Resource Center for the speedometer here, or the leaderboards, so you can place a billboard in your scene with all the high jump scores on it. And until then, happy building!